Hi, everybody. Welcome back to the self-check section 7.1 video. Let's take a look at what number two is asking us. So, a gondola carries skiers to the top of a mountain. It bears a plaque stating that the maximum capacity is 12 people or 2,004 pounds. That capacity will exceed if 12 people have weights with a mean of 167 pounds. So if one of those 12 people have 167 pounds of weight, then it will exceed that capacity. Now, because men tend to weigh more than women, a worst case scenario would be if all 12 passengers were men. So that would be our worst case scenario. 12 of the people are men. So men have weights that are normally distributed with a mean of 172 pounds. So mean is 172 and a standard deviation of 29 pounds. So standard deviation equals 29. So find the probability that if an individual man is randomly selected, his weight is greater than 167 pounds. So a couple key things to check out in this question. Here we're saying an individual man. So when we're talking about an individual man, we're not talking about a sample mean. What we are discussing here is just a normal distribution. So this would be more like section 6.2, where we just have a distribution, our standard deviation, our mean, and we find a probability. So let's go ahead and take care of that. So here's our distribution right here. We have a mean of 172, and we want to find a weight greater than 167 pounds. So 167 is going to be to the left, so 172, and it says greater. So what I need to do here is shade everything above 167. Okay, and that shaded region is what I need to determine. So my probability to do that within the calculator is going to be probability greater than 167. It's normal CDF, and it's going to be my lower limit. So within this shaded region, the lowest I can go is 167. And then the highest I can go is 9999. Okay, so 167, 9999, and my mean is 172, and my standard deviation is just going to be that 29. Remember, we're not talking about a sample mean. We're just dealing with one individual. So our standard deviation is just the regular standard deviation. Okay, so let's go ahead and calculate what that probability would be. So second distribution, normal CDF, we have 167, 9999, 172, and 29. So we hit enter and we get our probability 0.5684. Let's write that down. So we get 0.5684. And that is our probability of one man weighing greater than 167 pounds. So a good chance a man can be because it's greater than 50%. All right, so let's go ahead and check out part B. Find the probability that 12 randomly selected men will have a mean that is greater than 167 pounds. So here's where we are getting into the central limit theorem. Which is that 7.1 content. Let me write section 7.1. And this is where we change our standard deviation to be standard deviation over the square root of our sample. Okay, so once again, we want to draw a distribution. So 172 is our mean, greater than 170, 167 pounds. So we have the same setup, same exact setup. But this time we were dealing with 12 randomly selected men and their sample mean. So when we set up the probability, X bar greater than 167, because it's a sample mean, same process, normal CDF 167, 9999, 172, but now our standard deviation changes. It's going to be 29 over the square root of 12, because this 12 right here, that's our n, that's our sample size. So once we have this set up, let's go ahead and calculate that probability. So second vars, normal CDF, same exact setup as before, but what is changing is our standard deviation. So it's going to be 29 divided by the square root of, excuse me, 12. So we hit enter and we get our probability, which is 0.7248. Higher than if we pick one man, as you see above, it was just 50%, 56%. Now we're at 72%. So it's a lot higher chance with a smaller sample size. So this becomes 0.7248. Okay, let's move on to example 3 now. So that example 3 states in a recent study reported in October 29, 2022, the mean age of tablet users is 34 years of age. So this is mean equals 34, and a standard deviation is 15. And we have our sample size 100. So question A is asking, what are the mean and standard deviation for the sample mean of age of tablet users? So remember with the sample means, the mean stays the same. So sample mean is the same thing as the mean because it doesn't change, which is just 34. But our sample standard deviation changes. It'll be our standard deviation over the square root of the sample. So that's actually 15 over the square root of 100. Okay, so question B is asking, find the probability that the sample mean age is more than 30 years. So we have to use the central limit theorem here because of that sample mean component. So we'll have distribution here. Our mean is 34, where we want to know the probability greater than 30 years. So 30 will be somewhere to the left. I'm just going to shade everything to the right of 30 because we want to know more than 30 years. So let's go ahead and set up our work. So probability of X bar, because we're dealing with sample means, is greater than 30 is going to be normal CDF 309999 34 and 15 over square root of 100. 30 is our lower limit. We go all the way up to 9999, a really big positive number. And we have our mean and then our sample mean standard deviation. So Once again, let's go ahead and calculate this out. So second distribution, excuse me, second distribution, normal CDF, we're going to have 30, 9, 34, and 15 divided by the square root of 100. We hit enter, and that's our probability, a very high probability, 0.9962. So almost 100%. So we 0.9962. So probability from the sample mean that they're more than 30 years old is almost 100%. So last question, let's look at part C. So find the 95th percentile for a sample mean age. Okay, so same thing, distribution. We have a mean of 34. And I want to know the 95th percentile. So I know 95% is going to be way over here to the right, almost the entire distribution. Okay, so what I want to know is what that K value is, because I know this is 95%, the shaded region. So what I need to do is set up my inverse norm. So K equals inverse norm. I have my 95%. I have my same mean 34, but here's my new standard deviation because we're dealing with a sample mean. So it would be 15 over square root of 100. And if we put that in the calculator, we will get our desired result of 0.85, 34, 15 divided by square root of 100. And so we get our, excuse me, I use 85%. It should be 95%. Let's try this again. 0.95, 34, and 15 divided by square root of 100. And what we get is 36.46. Says one decimal place, so we round up to 5. So 36.5. So this 36.5 is the 95th percentile. Okay. And that's it for question 3. So that does it for the self-check video. Thank you for watching. We'll see you next time. Thank you. Bye.